In this video, we're going to talk about electronegativity and bond polarity. So in the previous video, we talked about covalent bonds sharing electrons, but these atoms don't always have to share them evenly. One element could have a greater share of the electrons than the other ones. And that's why we talk about bond polarity. So if you have one atom having more share of the electrons than the other one, we call that a polar covalent bond. And we can measure this with bond polarity. But the atom that has more electrons, we call it partially negative. And that's what this symbol is showing, that atom is partially negative. Hydrogen doesn't have as many bonds, so it's partially positive. We can write what's called a dipole moment, showing positive to negative end of the atom. And we can also show that in pictorial form, where blue is more positive and red, yellow is more negative. So this is just showing the share of the electrons. And when we're talking about covalent bonds, a lot of bonds have some degree of sharing and ion formation to them. And bonds are covalent if the electron transfer is incomplete to have a complete transfer, right? But if the sharing is unequal enough to produce a dipole moment, then you'll say this bond is a polar bond. And so let's just talk about some terms here. Electronegativity is the ability of an atom to attract bonding electrons to itself. And this increases left to right and from down to up, or top to bottom of your periodic table. So your most electronegative atom will be fluorine, going from left to right and bottom to top. And your least electronegative element is francium. Noble gases, no electronegativity, they're inert. And really, this is the opposite of atomic trend. Something is small, it's more likely to be electronegative. And when two atoms bond, the greater the difference in electronegativity, the more polar the bond, until you get a complete transfer of electrons. Then you can have a ionic bond. So here's a look at the periodic table. What I'm showing here is electronegativity, where fluorine's the greatest. Then you have oxygen, nitrogen, chlorine, and bromine being very electronegative. On the other side, your metals are not electronegative at all. And you have a big gap between your metals and your nonmetals. That is why you usually form ionic bonds. And you can actually calculate this level of polarity and what type of bond you have based on the electronegativity. So if you have atoms that have are the same type of atom bonding together, you have pure covalent, which is 50-50 sharing of the bonds. If the electronegativity difference is between 0.1 and 0.4, then it's not polar at all. It's more like equal sharing as well. If the difference in electronegativity is 0.4 to 1.9, as shown here, you have a polar covalent bond, where your electronegative ion will have more electrons than your positive. And if the difference is greater than 2, you have a complete transfer of electrons and you're 100% ionic. So here's the periodic table again, and I want you to take a second and see if you can decide what type of bonds these elements will have. So pause the video and try that out. Alright, so we have a covalent bond between Br and Br, be completely nonpolar, same electronegativities. If we look at carbon and chloride, the difference is 0.5, so you might have a little bit of polar character, not too much though. While carbon and sulfur, they are both 2.5, so you'll have no polar characteristics. These will be nonpolar. While Sr, which is all the way over here, and oxygen, the difference is greater than 2, so these will be an ionic bond. And with polarities, you can have what's called a dipole moment. And a dipole moment is just a bond or any material with a positive end and a negative end. And it's proportional to the differences in charge. So basically, the bigger the difference in electronegativity, the bigger the dipole moment. That's all that means, is that if you have a big difference in your electronegativities, you're going to have a big dipole moment. Yeah, more electron atoms are that share larger the atoms, the bigger the dipole moment. And that's it for this video. See you in the next one. Whoops.